My dear students, we are on the path of the discussions regarding the physics. One of it is the branch which is your the ray optics. In the ray optics, we discussed here the two parts. In the part 1, we have started about the reflections, but the completely about the idea of the reflections is now for this year it being here the omitted, and only the preliminary ideas we came to know. What is your the reflection process, and what is your the mirror, and what type of the mirror equation it will satisfy, and it is the different terms. Then we have discussed about the refractions. In the refraction, what are the laws of the refractions, and the importance part is it is the Snell's law, then the critical angle, total internal reflections, its applications, etc. But in our the last class, we discussed about the refraction on the spherical surface, and with it see the applications for your the thin lens formula and your the lens maker formula with the combination of the lens for its the power of the lens. So, on that class we have discussed that if the two lenses are in combined to each other, means the thickness or the separation between them is very negligible, which can be considered as your the 0, for which we have taken it is the thin lens, and for that one we have written that P is equals to P1 plus P2, where P is the effective power, P1 is the power of the first lens, and P2 is the power of the second lens. And today we are going to discuss the topics which concerns with your the refraction of the light through a prism, expression of the refractive index of the prism, the dispersion, angular dispersion, dispersive power, and your the lens combinations. Regarding this we will discuss today. So, let us now go to know if the two lenses are in combination with the each other, then what will it see the power of the lens. So, power of lens, in bracket you can write, that is your the in combination. Combination means combined. If the two lenses are combined together, suppose the first lens has the power P1, that is the first lens power, and P2 is your the second lens power. Then P, if it is the effective power, then P is equals to your the P1 plus P2. Up to this we discussed in our the last class. But if these two lenses are separated through a distance, if D is the distance of separation, then P effective is equals to P1 plus P2 minus D of P1 P2. This is its the formula. So, this power of the lens means that is your the 1 by Fe, means the power of the lens is the reciprocal of the focal length that we discussed. So, that is equals to 1 by Fe is equals to 1 by F1 plus 1 by F2 minus D. This P1 again that is 1 by F1, P2 is equals to your the 1 by F2. So, this implies 1 by F1 plus 1 by F2 minus D by your the F1 F2. So, if the distance of separation between them is very negligible, means they are in combination, means this D will be your the 0, then 1 by Fe is equals to 1 by F1 plus 1 by F2. So, this 1 by Fe is nothing but that is the Pe. This is equals to the power of the one lens. This is the power of the second lens. So, Pe is equals to P1 plus P2. So, P if it is the effective, Pe is the effective power, Pe is equals to the P1 P2. So, up to this we discussed. But now the question is, instead of taking your the two lenses, if it is a combination of your the lens and your the mirror, then what will be the its focal length and what will be its the image formation distance, that we have to calculate. So, that is your the combination of lens and mirror. Combination of lens and mirror means, let us have a lens and with here the mirror. So, this mirror is silvered at its the one side. If this is its the optical axis, an object is taken here, suppose the object is your the O. The question is, if the lens and the mirror, this is your the lens, this is the lens and this is the mirror. If they are in combination, if the object is at a O, then where the image to be the formed? So, students, first you think, if this is the lens, if the object is here, then how that image will be formed? The image is formed on the another side. But if this is the mirror, means what type of the mirror it is? Though this is it's the reflecting surface which is the inward, and this is the concave mirror. If this concave mirror is only there, if the object is here, then where your the image to be formed, that also you know. But on for this case, if the object is on the left, the image to be on the right, and for this case the image to be on the same side, because this is the mirror, means the reflection only to be happens there. So, now the question is, if the two are there, then what type of the condition it will provide? Suppose a ray is coming from your the object O. So, after the refraction, it is coming from your the air, All India Radio, this is the air, this is your the lens, and again this is your the air. So, when it is going from your the air to your the lens, means this is the rarer and your the denser. If we draw a normal, instead of going on that way, it will away from its the normal. Therefore, it will be your the refract in this direction, and it will fall on your the mirror. So, though this is the mirror and this side is the silver, the ray will not pass out on that side. Again it to be your the reflect, not refract. Again it to be your the reflect. So, it to be your the reflect. So, when it will the reflect, it will immediately will again to your the refract, and it will meet at a point on the axis. Let this is your the image. So, this is your the refracted one. Therefore, if the object is here, the image is also forming on your the same side. Means the object and the image, when they are on the same side, the effective one which it producing, that is nothing but the process of your the mirror it is satisfying. Not your the lens, but it satisfying the process of your the mirror. In case of the mirror, what will be the formula? That we know, if this is the object, this is the surface, this is the object distance is equals to your the u, this is your the image, and this is the surface, this is equals to your the v. If u, v and the focal length is known, and for your the mirror, we know that 1 by f is equals to 1 by v plus 1 by u for the mirror. But for the lens, we know that 1 by f is equals to 1 by v minus of the 1 by u. So, this is equals to 1 by f, v and u. U means your the object distance which is already provided. F means your the focal length, it is not provided here. And v is the image distance that we have to determine. So, if a lens and the mirror to be your the combined, the effective one will behave as a dash. It will come as your the short questions, not only in your the board examinations, but also in your the entrance examinations. So, the possible answers are your the it will behave as your the formation of the lens, as the properties of the mirror, or it is the combination of that one, or none of this. And the answer you will prefer that will behave as the property of your the mirror only. So, what will be your the value, how you will calculate here. So, here one have to determine the value of your the PE, means it is the effective power. First, you have to know what is the effective power. You have to calculate the value of the effective power, because the two things are in combination, it will give you the effective power. So, when the effective power will be provided, you see, first it goes through your the lens, again it goes through your the mirror, and again it comes through your the lens. Therefore, the effective power is the sum of its the individuals. The first individual means the first refraction is taking place due to your the refraction, means through your the lens. So that is the power of the lens. The second one, due to your this mirror, it gives you the reflection, so that is equals to your the power of your the mirror, means your the m. And lastly, it again goes through your the lens, so the power of the lens. So the required formula is PE is equals to PL plus PM plus PL. Are you clear to my students? Sir, why the two PLs are there? You see, first ray is going through your the lens, again it is coming through your the lens, means through the lens it is going and your the coming. Therefore, for that lens it will gives its the value for your the two powers, and one is for your the mirror, and this is your the PM. So this PE is equals to 1 by FE, this PL is equals to 1 by FL, this PM is equals to minus 1 by FM, and this PL is equals to the 1 by FL. Because the power is the reciprocal of the focal length. Sir, it is the reciprocal, it is the reciprocal, it is the reciprocal, it is the reciprocal. Here it is the minus, or why here it is the minus? Because this effective is behaving as the mirror. So for the mirror power and for the lens power, there is a negative sign. For the lens, the power is equals to 1 by focal length, but for the mirror, that is equals to your the minus of your the 1 by focal length. So this 1 by FL, FL is what? The focal length of lens. And what is the focal length of the lens? That we know. N2 by your the N1 minus 1 whole into 1 by R1 minus 1 by R2, that is equals to your the 1 by your the FL. As we have discussed in your the lens maker's formula. According to your the lens maker's formula, 1 by F is equals to mu minus 1 whole into 1 by R1 minus 1 by R2. This is the lens maker's formula. So for your the L means your the for the lens, FL is equals to mu minus 1, though this is the lens means the ray is coming from one medium to the another medium. If this N1 is its the surrounding one, and N2 is its the own medium's refractive index, means this N2 will be for your the lens, and this N1 for your the AR minus 1 by R1 minus 1 by R2. When the lens is provided, its radius of curvatures are also provided, so you can find out what is the value of the FL. So you have to substitute the value of the FL here and here. Next, it is equals to the minus 1 by FM. So how you will calculate the value of the FM? So students, if we go for your the next earlier two classes, you came to know that the radius of curvature, ROC, radius of curvature is equals to twice of the focal length. Means you know R is equals to your the 2F. This thing you know. So when R is equals to 2F means this FM is equals to, means FM means your the focal length, FM is equals to your the R by 2, so that is equals to your the R by 2. R is what? Radius of a curvature. Radius of a curvature of which one? For this mirror. So this mirror means it is the spherical in form. So the spherical mirror is what? Which is a part of a sphere. So though this is a spherical mirror, it must be a part of a sphere. So when it is a part of a sphere, the radius of a curvature we know. So this radius of a curvature value we know. So FM value can be calculated easily. So FM, again this FL value you know. So if you will put all these values according to the data which is provided in your the problem, then you can find out what is the value of the minus 1 by Fe. That you can calculate very easily 1 by Fe. But we know that 1 by F is equals to your the 1 by V plus 1 by U for this whole combination. So this 1 by Fe value you can substitute here. 1 by U means the object distance which is provided, that also substituted here. So only the determining value is equals to your the 1 by V, means you can easily find out what is the value of the V. So if a lens and the mirror are in the combination, then how you will calculate the value of its the image distance, this is its the process. So, the first thing is you have to find what is its the effective power. Effective power formula is equals to this one, in which PL is this, PM is this, and PL is this. By putting the values of the FL means from your the according to the lens maker's formula 1 by F is equals to this much. So, 1 FL will be your the this much, means this is equals to 1 by FL will be your the this much. So, you have to substitute the R1 R2 value, NL and your the NIR. NL means the refractive index. So, this is your lens in which material it being here the form. If it is your the made of the glass, commonly the value of the mu is your the 1.5, and in next one it is your the AR. So, the AR means your the AR refractive index is equals to your the 1. So, you can find, you can put the values of the mu here, and you have to multiply it by 1 by R1 minus 1 by R2 substitution, and you will find the value of 1 by FL. So, ultimately you will find the value of your the 1 by F. So, 1 by F you know, U value you know, after putting you will find your the value of your the V. So, if the problem will come regarding to this one, you first take its the data and put this application, and you will find its the result. So, as we came to know that when a lens and the mirror to be in the combination, then it is the required formula for your the power of its the effective value PE is equals to your the PL plus PM plus of your the PL. This is your the refraction and the reflection, both things are the happening. Next we will discuss what is your the refraction on your the prism surface. So, when the name being your the prism is coming, you must probably heard the name of the prism. In many more cases, you have seen some of the structures like that of your the prism. So, what is your the prism? First we will come to know. So, a prism is made of solid, homogeneous, transparent, refracting medium bounded by two plane surfaces inclining some angle. Inclining some angle. This is the basic definition of your the prism. It is made of your the solid. The prism is your the solid thing, and it is the homogeneous, means inside it everywhere the presence of the particles are same. Next it is the transparent, means the ray can easily pass through that one, and having your the refracting medium. Though it is the made of the particle, means it must have of the refracting medium, means its refractive index it will possess, bounded by your the two plane surfaces, then with inclining some angle. So, a structure of the prism generally comes to your the mind in the form of the triangle, but it is not completely of the triangle. You take a triangle and you take another triangle. Now, just you join them. So, this one will act as its the base. This is of the one plane surface, this is your the another plane surface. These two plane surfaces are inclining certain angle. That angle is depends upon the material in which it being your the made, and this angle is also depends upon in which angle of the inclination that two plane surfaces being your the taken. And for your the common sense, if you will have your the prism, means on my hand you can have that. If this is your the structure of your the prism, this prism has your the 5 surfaces. You see this front one, it is of one of its the surface, the back side is of the one surface, and these two hands with my the fingers, that is your the two plane surfaces, and the bottom one is its the another base. means it's another surface. So these two are the two sides, these two are the two sides, and the base is the one side, means it is made of here the 5. So one of the base is the this one, this is your the one surface, this is the one surface, and as you are looking this one, this is of its the front side, means which I am showing to you, this is the front side, and one of its the back side, means this one, means this is its the front side, its back side is the this one. These two are your the these two plane surfaces, they are inclining certain angle. Such type of the arrangement is known as your the prism. So generally in overall view, we just have the idea of the prism, means a triangle will come to your account. Suppose a ray to be the incident. So this ray is going from this medium to this medium. This is the plane surface, this is the plane surface, means here the it is bounded by the two plane surfaces. This is your the angle of the prism, and though this is the plane surface which separates your the refracting medium, inside it has its the refracting medium. So though this is your the air, this is your the material medium, and this is again your the air, the ray is going from your the rarer to your the denser, and that is your the transparent one. The transparent means the ray can easily easily pass, that is known as the transparent, means when this ray is coming, it can easily pass through that one. But according to your the refraction, you know that when a ray is going from one medium to your the another medium, it will not pass in your the straight way, it to be your the bend. Suppose you will draw a normal here. This is the incident ray, this is the normal. While it is going from the rarer to denser, it will come towards the normal. Means this ray, instead of going on this way, it to be your the come this way. So this is it's the refracted one. This refracted ray again coming to your the another plane surface. This is your the denser medium, this is the rarer medium. Let us now draw a normal there. So this is the normal. So instead of going on its the straight path, it will bend away from the normal. You see the normal is on this side, the ray to be passed on that side without your the deviation, though the refraction means the deviation is taking place. So instead of going along its the path, it will bend away. So this is its the final ray. So this is the incident ray, this is the normal. So this is the angle of incidence. Let us take this is your the I. This is your the normal, this is the refracted ray. Let us take this is the angle of refraction, that is equals to your the R1. Again this refracted ray will behave as your the incidence for your the this one. So this will be the angle of the incidence. Let us take this is equals to your the R2 angle of incidence, but I have taken by some name, that is equals to your the R2, and this is it's the final ray. This is your the normal, this is your the final ray angle, that is the angle of the emergence. So let us now name it. This is your the A, this is the B, this is the C, a ray which is comes, that is equals to your the PQ. After the refraction, it is going as your the QR, and finally it is emerges as your the RS. So my students, this PQ is called your the incident ray, this is called your the refracted ray, and this is called your the emergent ray. This is the angle of incidence, this is the one of the normal, say this is the N1, this is the second normal, this is the N2, and this is your the two normals are meeting at a point, let that is equals to your the N. And this is it's the final ray, and this is it's the initial ray. So if the initial ray to be passed, it will go in this direction, and this is the final ray, it is going in this direction. If we extend this final ray, it will meet at a point, and the angle which they are forming, that angle is known as the angle of deviation. That angle is known as the angle of deviation. So deviation means what? To go away from its own track. Suppose a student is going to the school. Instead of going to the school from some square, he or the she just change its direction. So the peoples who are observing to him or the her, they will say that that student is deviating. Means instead of going to the school, his path being your the changed. So you see, instead of going this ray to be your the straight, its path being your the changed. Instead of going straight on this way, its path being your the changed. This is its the final direction. This is its the initial of the path coming. So if it to be go along its the way, means if the students is asked you have to go to the school, means the path is a 1, means along that way he or the she to reach your the school. So instead of reaching the school, if the student is going for your the mall, then what will say that the student is being your the deviated. You see, instead of going straight, the ray is going in this direction. So that means that is your the deviated. So now you extend this extend ray, and now you extend this emergent ray, where they to be met, that is known as the angle of deviation. So this is the angle of deviation, that is your the del. So now you see that though the refraction is taking place, according to refraction, mu1 sin I is equals to your the mu2 sin R, we know. So that implies mu1 of a sin I we have taken is your the I, and mu2 of the sin R, that R we have taken as your the E here. Therefore you can say mu1 I is equals to your the mu2 E, means for your the very small angle of the incidence on the angle of the prism, mu1 I is equals to your the mu2 E. So this is one. And then we have to consider for your the AQNR, which is a quadrilateral, and QNR, it is your the triangle. Now comparing them, we will find what will be the refractive index. As we came to know that what is the definition of the prism, and how the ray which will come either from this side or to that side, it will how it passes, that we will came to know, and we already derived that mu1 of the sin I is equals to the mu2 of your the E, or sin I by your the sin E is equals to your the mu1 by your the mu2. Now you just observe your the quadrilateral AQNR, quadrilateral QNRA, QNRA. You see, this is the normal, and here it is the normal, means these angles are the 90 degree each. So 90 plus 90, that is your the 180 degree, and the remaining two angles means this is your the A and this is your the N, that is your the 90. These two are the addition will your the 180, because for the quadrilateral there are the 4 angles and the summation of the 4 angles is equals to the 360, but these two angles are the 90 degree because at the Q it is your the normal, at the R it is the normal. So Q and the R, they are the 90 degree each. Therefore angle of your the N plus angle of the A is equals to the 180 degree. Let that is equals to the equation A. Again in the triangle QNR, again in the triangle QNR, you see this is your the QNR, means this angle plus this angle plus this angle is equals to your the 180 degree. Sum of the 3 angles is equals to 180 degree, means R1 plus R2 plus N angle is equals to the 180 degree, that is the equation B. So if you compare the equation A and your the B, this is your the 180 degree, the right hand side is the 180 degree. Therefore the left hand side must be your the same. The common is your the measurement of the angle N. So angle N plus A is equals to 180 degree, angle N plus R1 plus R2 is equals to 180 degree. So comparing these two, we will have R1 plus R2 is equals to your the A. R1 plus R2 is equals to A. This is equals to the, say this is C. Again the angle of deviation which we discussed, angle of deviation, this is the angle of deviation. Suppose you will give this is equals to the name of your the K, this point where it meets, that is equals to the K. So in the Q, K, Q, R, in this triangle, this is your the deviation angle, that is your the deviation angle, means that deviation angle del, which is it's the exterior angle. The exterior angle, we know that it is the sum of the two interior opposite angles. Means this angle is the sum of this angle, this tick mark and this tick mark. You see, this is your the triangle. So, this is the exterior angle, it is the sum of these two angles. So, what is the value of this small angle? This tick mark angle is equals to how much? You see, if the ray to be the go in the straight and this is your the normal, ray will go straight and this is your the normal drawn. If this is equals to P, this is your the Q, and this point anywhere we have taken that is equals to your the K, means this is equals to your the I angle. Suppose this is your the normal N, this is your the I angle. So, these are the two straight lines. If this angle is I, means this angle is equals to your the I. Instead of going this ray is the straight, it being your the bends. So, this angle from your the normal, you see, this angle we have taken for your the R1. So, this is your the R1. So, R1 plus this is equals to your the this whole one. This whole one is nothing but your the I. But this one is equals to your the R1, means R1 plus the tick mark angle is equals to your the I. Then this tick mark angle is equals to your the I minus R1. So, this tick mark angle is equals to your the I minus R1. Similarly, if we will go for your the this tick mark one, you see, this is your the angle, this angle we have to calculate. So, this is your the normal, this is your the straight line, and this angle is equals to your the E, means this total angle is also equals to your the E. When the two lines are the intersecting, if this angle is equals to E, means this angle will be your the E. So, if this angle is equals to E, means this total angle is equals to the E, but this angle is equals to your the R2. So, R2 plus this tick mark, R2 plus the second tick mark is equals to your the E. So, this tick mark is equals to your the E minus of your the R2. So, this tick mark is equals to your the E minus R1, this tick mark is equals to your the E minus R2, and this del is your the exterior angle. So, that exterior angle is the sum of that two tick marks. So, the first tick mark, so this is your the first tick mark, this is your the second tick mark. If we take, this is the second tick mark. The first tick mark is equals to your the I minus of your the R1. The second tick mark is equals to your the E minus of your the R2. So, this is equals to I plus E minus R1 minus will be taken common, that is equals to R1 plus R2. So, this del is equals to I plus E minus R1 plus R2. But you see, according to the equation C, R1 plus R2 is equals to your the capital A. So, this is equals to I plus E, R1 plus R2, R1 plus R2 is equals to your the capital A. So, del is equals to your the I plus E minus of A. It is very how much V you can add with that one. Very applicable formula for your the prism. So, del is equals to your the this one. Okay, are you clear? This del means your the angle of your the deviation. So, this angle of a deviation will be minimum when I is equals to E or R1 is equals to your the R2. If I is equals to E, say that is equals to your the I, R1 is equals to R2, say that is your the R. So, if we put the values are here, this angle of a deviation means del will be your the minimum, that is equals to your the del M. So, del M means this del will be your the del M when I is equals to your the E. When I is equals to E, if we have taken as the I, means the I plus I minus of here the A is equals to here the R1 plus R2, but R1 and R2 to be here the same, so that is equals to here the R plus R. So that is equals to here the 2I minus of here the 2R, implies your 2I is equals to 2R plus a del M. This minus 2R came to this side, 2I is remain. So 2I is equals to minus 2R come to this side, that is equals to plus 2R, and del M is equals to del M. So 2I is equals to 2R plus del M, and I is equals to here the 2R. 2R is equals to here the how much? That is equals to here the A, because I1 plus of here the I2, that is equals to here the 2R. I1 plus I2 is equals to here the A. So this 2R that we have taken as here the A plus a del M, that is equals to the 2I. So I is equals to that by here the 2. So angle of incidence is equals to here the A plus del M by 2. Similarly, when 2R is equals to here the A, this R1 plus R2 is equals to A, means 2R is equals to A. So what is the value of R? R is equals to here the A by 2. So I is equals to A plus del M by 2, R is equals to here the A by 2. Then if we will put it according to your the refraction process, though the heading is your the refraction on your the prism surface, refraction on prism surface. So we are going to find what will be the refraction on your the prism surface. So when the refraction is taking place on your the prism surface, for the refraction you know mu is equals to your the sin I by your the sin R. Whenever the refraction is taking place, means it will satisfy the Snell's law. We know that according to the Snell's law, mu is equals to sin I by your the sin R. But I is equals to how much? A plus del M by 2. So that is equals to sin I is equals to your the A plus del M by 2 by your the sin R. R is equals to your the A by 2. So this is equals to your the mu. So when the refraction is taking place on the prism surface, your refractive index mu is equals to sin A plus del M by 2 divided by your the sin A by 2. So my dear students, you have gone through your the practical classes. In that practical classes, you know in your the theory only the formula mu is equals to this much, and this is its the complete derivation. So when you will face the examination for the particularly for the board examination, the question will come in your the two different way. And if it is written that prove that mu is equals to your the this much, likewise the question will come directly. Or it can say that find your the refraction, how it is happening for your the prism surface, or the question will come find the required formula for your the refraction on your the prism surface. Likewise the question you will face. So this del is equals to mu is equals to A plus del M by 2 by your the sin A by 2. In your the practical also you know the graph of I versus of your the del M, means angle of incidence and your the angle of the minimum deviation. Means that minimum deviation, after knowing your the deviation angle, suppose this is the angle of a deviation, this is your the incidence angle, and this is your the angle of the deviation. As we know from your the practical, the graphical form will be your the likewise. Means it shows that suppose this is the point A, I am taking this is the point B, suppose this point is equals to the C, and this point is your the D. So at the point A, this is its the angle of incidence and this is the angle of deviation. For the point B, this is your the angle of incidence, this is your the angle of deviation. So what type of the idea now you are getting? As the angle of incidence increases, the angle of deviation is your the decreases. But if you will go for the point C, then from this to this is the angle of the incidence, and at the point B from this to this is the angle of incidence. So in comparison to your the C with your the B, the angle of incidence increases. When the angle of incidence here the increases, the angle of deviation you see now it is your the increases. But earlier we came to know that when the angle of incidence is your the increases, the angle of deviation decreases. So you cannot say directly that if the one will increase means the another to be your the increase, or the another one to be your the decrease. So that is your the dilemma in your the practical evidence of your the I with your the del m. So this value of the b, which is it's the minimum value of your the angle of your the deviation. So that is known as your the angle of your the minimum deviation. And the graph which you are looking now, this is not your the perfectly of your the parabolic shape. So the points to be your the noted here. First point, the angle of deviation with angle of prism not provides a parabolic form. This is not a parabolic form. If it will have the parabolic form, on the both side it will give you the symmetrical, but it is not your the symmetrical one. Second, for a particular angle of incidence, the deviation angle is minimum. The deviation angle is your the minimum only for a particular angle. You see the angle of deviation only for a particular point. And the third one, except the minimum deviation, the other angle of incidence, have TW2 angle of deviation. Have not 2, you can say here the more angle of deviation. You can have here the more angle of deviation. Suppose what is its meaning? Except minimum deviation. This is the minimum deviation. Except that one. Suppose I will take this value. So for this value, this will be your the deviation angle. And if you will go on this straight way, this is also your the another deviation angle. So here if you will draw a normal, in between them you will have your the different angle of the deviations. So this is your the most 3 important points you came to know if you will draw a graph of your the I with your the dm. As we know that if we plot a graph by taking your the angle of incidence in your the x-axis and angle of the deviation along your the y-axis, the graphical form is the likewise, about which we have written here the 3 points. So now if this angle of incidence and your the angle of the prisms, they are to be of the very smaller values. Next one we will consider for small value of angle of incidence, which is your the wife of Aja, angle of incidence, angle of refraction, that is the smaller, and angle of prism. You know that mu is equals to your the sin I by your the sin R1, that is equals to, and mu is also your the sin E by your the sin R2. As this is your the prism, this is your the incident, refracted, emergent, incident, refracted, emergent, this is your the normal, this is your the normal, as we have given P, Q, R, S, incident normal, this is the incident ray, this is the angle of incidence I, and this is your the normal, this is the refracted, that is equals to the R1, this we have taken as the R2, and this angle is equals to the E. And when the refraction is taking place at the point Q, means your the refractive index will be the sin I by your the sin R1, means for this side it is the angle is the I, so sin I, and this angle is the R1, so that is equals to the sin R1. If the incidence to be taking place on this side, you can write that sin E by your the sin R2, means this will be the angle of the incidence. The question is, sir, how it will the angle of incidence? It is the angle of the emergence. So according to the reversibility principle, you can just rotate this angle, means this rotate your the ray. This ray is your the RS. If you make your the plot a mirror here, and it is your the perpendicular to that one, and according to the reversibility, if a ray is coming straight on your the surface, and this will be the normal, the ray is also coming on the same direction, it to be your the reflect along your the same direction. So this will be your the SR, means suppose for this one a student is here, a student is observing this is it's the emergent, but at the same time one can visualize that this is also the angle of the incidence, and this is your the another student is here, say. So this is your the angle of incidence, but if the ray will come to that side, it will behave as the angle of the emergence. Therefore, but both the cases are happening on your the same material, therefore the refractive index will be the same. As we know that the refractive index will vary if the material's nature to be the change. Though the same material is there, therefore the mu value will remain here the this one. Therefore, for the smaller value, this sin I will be the I, this R1 will be the R1, and this mu is equals to your the E by your the R2. So this implies I is equals to your the mu R1 and E is equals to your the mu R2. But we know that I plus E is equals to your the A plus of your the angle of deviation. So this is equals to I plus E, means that is equals to mu R1 plus mu R2 is equals to your the A plus of your the D. So if you take any mu is the common, R1 plus R2 is equals to the A plus of here the D, means deviation, that del we have written in the symbol for the del. So this R1 plus R2 is equals to how much we have written as the A. So mu plus A is equals to your the A plus of here the del. So del is equals to your the mu A minus of here the A, means if you take here the A is the common, that is equals to the mu minus 1, means del is equals to your the mu minus 1 into your the A. This is another important relation. Del means the angle of a deviation, which is related with your the refractive index and your the angle of your the prism. So these are the important formulas for your the refraction on your the prism surface. Del is equals to mu minus 1 into A, and mu is equals to your the sin A plus del m by 2 by your the sin A by 2. But most of the students, they are writing in this way, mu is equals to sin A plus del m by 2 divided by sin A by 2. I am not saying that this is the wrong, but the way in which he or the she has written, that is your the wrong. You see, the is equals to sign and the divided, if they are between your the two lines of the is equals to the divided sign must be remain. Therefore, when mu is equals to this one, so between your the two lines this division sign should be remain, then it looks here the very good. Mu is equals to the this one. You see, mu is equals to between your the two straight lines the division sign. Here also between your the two the division sign, but the is equals to will remain at one place and the division is remaining in another place. The formula is not here the correct, but the way of the writing is not here the correct. So these are the formula. By taking this formula, we will now solve one or the two very interesting problems. Suppose question number 1. This is a prism A, B, C. Suppose a ray is incident and this is its here the normal. This angle is given as your the 30 degrees say. And if this is your the equilateral triangle, if you will say this is equals to 60 degree, this is equals to 60 degree, this is the 60 degree, and this material is made of the refractive index say here the √3. The question is find del and E, means the angle of deviation and your the angle of emergence. So how you will find these two values? Solution. You see, this is the incident ray, this is the normal, means there will be a refracted ray, and this will be the angle of the refraction, that is equal to the R1. Here the refraction is taking place at this point. So according to your the Snell's law, mu A sin 30 is equals to mu P of sin R1. Clear, my students? This is the point where the refraction is taking place. Where the refraction is taking place, the Snell's law to be satisfied. The Snell's law is generally you know mu 1 sin I is equals to the mu 2 sin R, means I is where the refractive medium of that side, R is where this is the refractive medium of that side. You see for this one, angle of incidence is 30, so the refractive medium of that side. So that side means beyond your the prism, this side is your the AR. So I have written mu for your the A, means your the refractive index of AR of sin 30, refractive index of the P means the prism of your the sin R1. So this mu A for the AR, that value is equals to the 1, and the sin 30 is equals to the 1 by 2. Mu P means the refractive index of the material, it is given is √3, and this is equals to your the sin R1. So this is equals to your the sin R1 is equals to your the 1 by of your the 2 √3 of the 2 √3. So this is equals to, suppose the angle of incidence instead of the 30, to find the accurate value, suppose you will take this is equals to the 60. So this will be your the 60. This 60 will be your the √3 by your the 2. So this √3 is the cancel. So that implies sin R1 is equals to the 1 by 2, means your the sin 30, means this angle now it came to know that one is equals to the 30. This angle now it came here the 30 degree. So again this is your the one, means there will be the emergent. So this is, say this is your the emergent one, this is your the normal. So again the refraction is taking place here, and this angle is equals to your the R2. For your the prism you know R1 plus R2 is equals to your the A, and you see if the R1 is equals to your the 30 and R2 is equals to your the A means your the angle of a prism. Angle of a prism we already taken, that is the 60. So this is equals to 60, means your the R2 is equals to your the 30. So this R2 value now it comes here the 30. But the question is your the to find your the del and your the E, and to find that one, this is the refraction is taking place according to your the formula, mu P of your the sin 30 is equals to mu A of your the sin of this angle, means your the E, that is equals to your the sin E. Because you see this is your the incident, this is the refracted, Snell's law, the refractive index of its the sine of that side, means mu P of sin 30 is equals to your the mu A of your the sin E, because this E on your the AR medium, therefore the refractive index of the A, mu P means the refractive index is your √3, sin 30 is equals to the 1 by 2, mu A is equals to your the 1, and sin E. So sin E now it is equals to your the √3 by 2. √3 by 2 is the sin E, means √3 by 2 which value of the sin, that is equals to your the 60. So sin 60 is equals to your the sin E, implies E is equals to your the 60. So our aim was to find the value of the E. Now this E is equals to your the 60 degree. Then is your the del. How will you find the value of your the del? So del means you already came to know that del is equals to I plus E minus A. This formula I said very important. So, I plus E minus A. So, I means the angle of incidence. Angle of incidence is the 60 plus E minus A. A is equals to how much? 60. So, 60 plus 60. 60 means E. E del is equals to your value is equals to your the E. So, del is equals to your the E. That value you came to know. So, with this, if I will give you some more problems, you can also find on that way. So, the most three important formulas for the mu, one is the A, one is the del. These three things if you will remember, then it will helpful for your the examinations. Thank you very much, my students.